Let's learn some applications of the mean value theorem. Suppose we have a continuous function f on the interval 2, 7, and we don't know much about this function, but we know from some data that its derivative bounded by -5 and 3. So let's say we know the speed of the rocket, but not the location of it, right? The distance. And we know that this is not exact speed, but we know that at least it is from -5 to 3, slowing down, speeding up. Can we figure out what is happening with f of 7 minus f of 2, some difference of two distances, if I'm using example of speed and distance? Yes, we can. The row theorem says that it guarantees for the continuous function on the interval 2 and 7 that there will be a point C such that the derivative at C definitely gives us f of 7 minus f of 2 divided by 7 minus 2, right? So we can calculate at least the denominator, it's 5, and f of 7 minus f of 2 stays like so in the numerator. That's what we know. Basically, we're talking about the slope, if you can see that. The change in output over change in input on the interval 2, 7. Here you go. And that's what the connection with the derivative. Well, we also know that derivative is bounded by those two values, -5 and 3, for all x on 2, 7. It says it here. Thus, using this knowledge, we can now say that this derivative is between -5 and 3, right? So f of 7 minus f of 2 divided by 5 is also between -5 and 3, not just at C, because it says for all x on 2, 7. And C is on that interval based on the mean value theorem. Now you can simplify and answer the question. We were asked what is happening with outputs at the endpoints, endpoint of f of 7 and endpoint of f of 2, and the difference between these two. So we are asked about this numerator of this fraction. Change in outputs is bounded by, multiplied by 5, it's going to be -25 and 15, and that answers the question. Hopefully that makes sense.